These are the frequently asked questions for Algebra 2 for Lesson 5-2, Day 1. Starting with number 7 up there, it says we are to write each polynomial in factored form and then check by multiplication. Well, I'm probably not going to check for you, but what I will do is go through and factor this with you. So x to the third plus 7x squared plus 10x. As you're writing the problem down, you should notice I seem to have an awful lot of x's there. So I'm going to factor out that common monomial of x, and that will give me x squared plus 7x plus 10. Again, you can think of it as dividing every term there by an x when you factor that out. And then I notice that the 10 is not a perfect square, so what I need to do is think x times x will give me x squared, and in the back I need two numbers that multiply to 10 and add to 7, and that would be 2 and 5. And so in factored form here, we have a monomial and two binomials for that one. Then number 11, we have x cubed plus 8x squared plus 16x. And again, you should notice, wow, I seem to be writing down a whole lot of x's. So we'll take an x out of all of those, and it'll look like so. Now, that one, hopefully you're thinking, wait a minute, that might be a perfect square trinomial because this is x squared and this is 4 squared. I wonder if that middle term works. So is x times 4 times 2 equal to 8? And sure enough it is. So we write that perfect square trinomial as a binomial squared, and that will be x plus 4 that will make that happen. So again, we're still doing the factoring the way that we did when we learned factoring. You know, factor out a common monomial factor, look for special patterns, and then just do general factoring if you need to, if nothing else is working at that point. All right, the next one is number 19. And in 19, we are going to write a polynomial function that has a zeros of 5, 6, and 7. So I remember that these always come from a factor, which means in the parentheses it was x minus something, and when you set that equal to 0, then you were getting a solution to figure out what would make your parentheses equal to 0. So in this case, they're saying one of those had to be x minus 5, because again, if you solve that, you're going to get 5. And then one of them had to be x minus 6 in order to get a solution of 6. And the other one had to be x minus 7. So we're writing a polynomial function, we'll just call it f of x, and it has the factors x minus 5 times x minus 6 times x minus 7. So now what I need to do is multiply those together. And what I will do, since there isn't any special pattern here, is I'm just going to go ahead and multiply those last two together and use FOIL on that. That will give you x squared minus 7x minus 6x will be minus 13x, and a negative 6 times a negative 7 is going to be a positive 42. Then what we have is a binomial times a trinomial. So what we have to do is take the first term, which is an x, times everything in the second set of parentheses. So x times x squared gives you x to the third. X times negative 13x gives you negative 13x squared. X times 42 gives you 42x. Then you go back through again, this time multiplying everything by negative 5. So minus 5x squared, and then plus 13 times 5, which is going to be 65x. And then we have negative 5 times 42, and that will give us a negative 210. Now I'm going to go back and just add together, combine any like terms. I only have one x cubed term, but I have a negative 13x squared and a negative 5x squared, so that's negative 18x squared. Then I have a 42x and a 65x, and that's 107x minus 210. So that's my polynomial function that's going to make that happen. And just like we talked about in class. This is another thing that you just want to do slowly and surely because there's a lot going on and you want to make sure that you keep track of everything. Then, number 21. This one has zeros at -5, -5, and 1. So again, I think about the parentheses and how that came to be x minus, to be a -5, I'd have to put x minus a -5, which would be x plus 5. So I'm going to have two of these x plus 5s and then an x minus 1. Because again, if you set each one of those parentheses equal to 0, you'd get -5, -5, and 1. So I'm going to call this one g of x, just to have something a little bit different. And I notice in this one that I have the special pattern of the x plus 5 squared. So this time I'm going to put the x minus 1 out front because that's nice and easy to multiply by the x and the 1. And just go ahead and either do the pattern for a binomial squared or do the FOIL on it and you get x squared plus 10x plus 25. Then we will go ahead and distribute the x and get x cubed plus 10x squared plus 25x. And then we'll go ahead and subtract because we have a -1 times x squared, a negative x squared minus 10x minus 25. Now it just so happened I kind of ran out of room as I was going through this one, but you can see that it's advantageous because now my squareds are lined up, my x to the firsts are lined up, so I'll have x to the third plus 9x squared plus 15x minus 25, and that will take care of number 21. The next one that I wanted to do up here was number 25 with zeros of 0, 0, 2, and 3. So, hopefully, when you're thinking about your parentheses here, you realize, wait a minute, x minus 0 is just going to be x. So I'm going to call this one f of x, but I realize that this is just x and this is just x, so it's going to be x squared times x minus 2 times x minus 3. So really what I have to do is FOIL those back two sets of binomials there and then just distribute the x squared. So by doing the FOIL, we'll get x squared minus 5x plus 6, and then we go ahead and distribute the x squared, and that's x to the fourth minus 5x to the third plus 6x squared. And that one is all done. So kind of a unique one there when we have those as zeros. Then, number 58 says, which expression is the factored form of x cubed plus 2x squared minus 5x minus 6? Now we haven't shown you the method to factor a polynomial with 4 terms yet. I'm going to do that in just a second. So for this one, if you don't know how to factor by grouping, what you would do is you would just multiply all of those together until you got the one that gave you x cubed plus 2x squared minus 5x minus 6. That's a test-taking strategy. You know, it's multiple choice, so that's what you do. But I am going to show you factoring by grouping. I will be teaching you this in class. Our mind works best by memorizing groups of 3. So that's why our social security number is broken into 3. Phone numbers are broken into 3 different sections. Combinations for lockers in 3 different sections. And so what we're doing here is we're going to try and trick our brain into seeing a factor that it can't see. Because looking at this right now, you know, your brain is not going to pick up on what you could pull out of all of these. So what we would do is we would take these first 2 terms and we would say, all right, what can I pull out of just those 2 terms? And that would be x squared times the quantity x plus 2. In the back, when we group these two together, we see that we have a -1, and that's all we can pull out. So when we get to factoring by grouping, we're going to be able to tell this one isn't actually factorable by grouping, because what has to happen when you factor by grouping is that what you have in the parentheses there has to be the same thing. So I wanted to cover both methods, and it turns out that our factoring by grouping will not work for this specific polynomial. So what you're going to have to do is just go through and multiply all these together until you get the one that works. Now there should be some dead giveaways for you here about certain things. You might want to use the process of elimination first, because that first term is just x cubed. That means this one is out, and that's because it has this 2 in front. And so that isn't going to work there. And again, you can just kind of do the quick and easy ones first and see if they work. So for f, we would have x minus 6 times, well, x plus 1 times x plus 1 is x squared plus 2x plus 1. Then we could go ahead and distribute the x and get x cubed plus 2x squared plus x, and then minus 6x squared minus 12x minus 6. And this will give you x cubed plus 2x squared minus 6x squared is minus 4x squared. And then an x minus 12x will be minus 11x minus 6. That doesn't match, so that one's out. And the other two, as you look at them, you might check on the signs and see which one you realize is going to be the one that will give you the 2 negatives in the back. But truly what you do is you just multiply them out. We know f isn't going to work, so you go after g. And g, I think it would be easiest if I put the x plus 1 in front and did FOIL with the other two first. So with the x plus 3 and the x minus 2, we'll get x squared plus x minus 6. We would distribute the x, so x cubed plus x squared minus 6x. Distribute the 1 plus x squared plus x minus 6. And then we'd have x cubed plus 2x squared minus 5x minus 6. And that one ends up being the correct one. So again, just thinking about the signs there, we could kind of eliminate I and just go with G. Now for number 59, you have to remember a formula from geometry, or you can look it up in the back of your book, and that's going to be for the volume of a sphere. And that actually is a formula that has been on several game shows where you have to know trivia in order to move forward and around. And it is 4/3 pi r cubed. Actually was in a movie as well. One of the Star Trek movies was reciting the volume formula for a sphere. So it says a ball with a 3-inch radius has a volume of v sub 1. A second ball has a 9-inch radius and a volume of v sub 2. Which equation represents the volume of the second in terms of the first? So what we want to notice here is that both formulas are going to require the 4/3 and the pi. What we're really asking is, how are the radii going to be related? And the radii are going to be related in terms of cubes. So if we are to take 3 and put it into that formula and cube it, we're going to get 27. If we take the 9 and we put that into the formula and cube it, we get 729. So they're really asking, how do these compare? Well, then that means we want to go ahead and take 729 and divide it by 27 and see that it is 27 times as much. So the second one, the larger one, is 27 times the first. And that is, of course, answer B up here. And so that's the one that we want to choose. Again, there are formulas in the back of the book, so you can look those up and go from there. And let's see if I had anything else here. Numbers 68 and 69. Yeah, you probably don't need my help for these, but I'm going to go ahead and give it to you anyway. It says solve it using any method, and I would choose factoring. So I'm looking at 68, and I realize this is going to be a combo method problem because there's not a common monomial factor, and it's not a perfect square problem. And in the back, I need two numbers that multiply to a positive 3, but add to a negative 7 there in the middle. So those are going to be negative numbers. And then doing outside times outside and inside times inside, 2 times negative 3 is negative 6, 1 times negative 1 is negative 1. So that gives me the order that I need to use. And it is first and first, so 2x and 1x. Last and last, minus 1 and minus 3. So then to get my 0, I'm going to set 2x minus 1 equal to 0, add the 1 and divide by 2, and get 1/2. And this one, probably most of you just looked at it and said, that's going to be x equals 3. So that's the easiest way to solve that one. Number 69, there's no middle term, so go ahead and add the 25 to both sides, then divide by 4. And take the square root of both sides, remembering that whenever we write down the square root symbol to solve, we have to put our plus or minus in there. And then go ahead and take the square root of 25 and the square root of 4. And we get plus or minus 5/2. That should do it for this section.